Hello, my name is Sean, and welcome to my Unreal Engine 5 twin-stick shooter project. I'm just going to quickly show the overall gameplay, and then I will dive into the implementation. So, here we have a twin-stick shooter character that has a gun that is controlled with mouse controls and keyboard controls if we want to. However, I much prefer the mouse controls. You can see we have ragdolling enemies that can be killed, and then we'll have an explosion effect on death. We can also shoot our physics objects that are throughout the world. I have this one highlighted with bone colors being shown that you can shoot, and objects will fall down. And then over here we have a better example of those physics objects with the proper textures applied. Here you can see that the player will take damage and eventually die if hit by the enemies. We can also take damage and walk away, and we will stop taking damage, and then we can also die again. Yeah, so that's the overall gameplay in this demo. When we kill enemies, we get some score added to our score counter as well. And overall, it was a fun project to develop. If we disable ragdolling on the enemy character, we can also see the default animations. Or not default animations, but the animations that we implemented on the enemy. So, if you shoot the enemy, they will die and play a little death animation, like that. But I much prefer the ragdolling, and when you see the enemy go flying. But that's just my personal preference, so that's why I made it a easy to modify setting in-game, and you can choose which one you prefer. So, some of my blueprints are my enemy character blueprint. This top part here calculates the new health of the enemy, and once they've died, if they have died, it will set the collision response to world dynamic objects and pawn objects to be disabled. And then it will also add a score to the game mode by the set amount of score. So the default is 500, which could be edited if we wanted to. Then it disables the enemy controller and enables physics on the mesh if ragdoll is true. Otherwise, it goes around and still does the delay. And then there's also the slight change here where when the enemy is killed, if it's a ragdoll, they'll stay around for a second so that the body is affected by the explosion effect that we spawn when the enemy dies. If not, then the explosion effect just plays at the same time as the actor is destroyed. Over here, this damages the hero by the set damage amount that the enemy does. So this one is 20 by default, but we could also change that if we wanted to, using the variable and for each unique instance of the enemy class. This starts damaging the player when the overlap begins, and will damage once every 2 seconds. It attacks twice per second. So, and then this will stop the attacking if the player leaves the enemy's radius of attack. Over here is the AI enemy and how they find the position. So every second it updates the new target position to the current position of the player character. This is a purely performance blueprint for my chaos destruction system. I added a disable field, and what this disable field does at a high level is any physics objects that enter it that are caused from the chaos system will have their physics disabled, and that saves a lot of performance, especially when you're dealing with thousands and thousands of physics objects like are created when you destroy all the rocks and blocks in the scene. So yeah, this just creates this part removes any previous persistence fields that may exist in the world. It adds a disables field with the size and fall off area specified here by the size of these boxes in the viewport. And then we can scale it in the scene to whatever size we want. The fall off effect is none that I have set. You could set it to fall off and be different effectiveness at different ranges, but I just wanted it wherever it was, it would disable it completely. The enemy spawner just spawns an enemy of BP enemy character class within a random point within the given volume. If there's less than the maximum number of enemies, which I have specified to 10. The explosion class plays a explosion sound, which I found on freesound.org, at the location of the class when it spawned, and then it also plays a explosion particle effect from the starter content. After 0.2 seconds, the actor is destroyed. And it also has a boom force, which makes them go flying. I played around with tweaking the values enough so that the ragdolls went flying a little bit, but didn't go so far, or didn't send other actors too far, so that they... Because if they went too far and flew out of bounds, they wouldn't necessarily die, but they wouldn't respawn, so eventually you could run out of enemies or run down to one. So I wanted to avoid that possible bug. It's not super likely with higher values, especially with the larger size of the arena that I have added, but it is possible, so I wanted to avoid that scenario. The external strain, this is the magic of how the destruction system works. So on spawn, a field with the specified size and scaled radius specified by the sphere collision object of the strain is added to the scene. Again, I have a linear fall off style, so instead of a logarithmic, I just wanted a bit of a easier to manage fall off style, because it's kind of hard to get the strain to work properly, especially on an exterior object. It's more meant for static destruction. Like, you could have like an effect and then trigger it when an explosion happens, but it's not actually the explosion causing the effect. But I wanted to have it on my game do that, so I have to do a linear fall off. And then, yeah, so it adds that field, and then right the next frame it deletes it, because I don't want it to have its own collision, which it does have its own collision. I don't want it to interact with the bullets or anything like that, or block the player and have invisible colliders, so it just deletes automatically. It instantly affects the scene anyway, so it doesn't need to stay around for long. This is the hero controller. So right at the start, we just set the mouse cursor to be visible by default. We're also apparently auto-saving out-of-date packages. And yeah, so that is just for our mouse controls, which I'll explain in a bit. This part sets up the weapon and attaches it to the gun socket, which we created on the skeletal mesh of the hero character. So if we go into our viewport and we go on the mesh, we added a socket into the skeleton of the hand, which we right now have previewing as the gun, so that we can see what it'll look like when the player's holding it. And I had to make sure, especially with the mouse controls, that it was directly pointing forward. Otherwise, it would not look right. So I previewed it with the rifle hip to make it point directly forward, because the bullet comes out depending on the angle of the gun. So it had to be pointing directly straight forward, or else you could easily tell that it wasn't exactly matching where the mouse was. But back to the hero character, to the event graph. This sets the player spawn point right at spawn. It just is where the player started. It will respawn them when they die at the exact same spot. This just adds the HUD to the world right over here. And this part is responsible for movement. So our input axis move up, which is our W and S keys. Yeah, it's just the scale value is by the axis value. So down is negative, forward is positive, and right is positive and left is negative. We here set if the left mouse button is down or up. So this is how we can shoot, by holding down the mouse button instead of holding a direction. This makes the player rotate towards the mouse location. So we get the location under the cursor, which is got here using a get hit result under cursor by channel, and then we break the hit result and get just the location and return that, which is, yeah, it's interesting. It was an interesting experiment making this work. And then the follow mouse is to set the rotation based on where the mouse is in the world in relation to the player, which was also interesting to do because I got to do a little bit of vector math, getting the difference and direction between two vectors. Yeah, so if we go back to the event graph, we can see that these are called when every event tick, because we want the player to have a smooth follow of the mouse. It also doesn't play when the player is dead, otherwise you could get a spinning body on the ground, which, admittedly funny, does not feel like a bug-free experience. Over here we have our implementation of keyboard controls, which still work. I prefer I distinctly prefer the mouse controls instead of keyboard controls. It just doesn't feel right to me, the keyboard controls, which is why I wanted to do that addition. And this part over here is just, it shoots the weapon if the mouse is down and stops and releases the trigger if the mouse is up. Over here, this is where the enemy can take, or not the enemy, where the enemy can deal damage to the player, so the player can take damage, and where they can die if their health is less than 0. So, if that happens, we disable input, we release the trigger, because if you don't release the trigger, the player can sometimes keep on firing infinitely. And then after a 3-second delay, the players respawn, the old weapon is destroyed, and the old player model is destroyed, and the player takes possession of the new BP hero character that is spawned in at the old spawn point. Over here is our projectile. This tests if the object that's overlapping implements the I damageable interface, which means that it is a enemy, basically, in our sense, or the player, but we have it set so that the player will not hit it. If it is, then it affects health. If it's not, that means it's a wall, and that's where we spawn in the strain field at the site of collision. Yeah, so we just have a little sequence where we do the same thing here, and then after that, we spawn in the external strain. We have to destroy the actor before we spawn in the external strain, or else you create an infinite loop where the external strain spawns, causing an overlap, which fires all these events. It's not pretty. Yeah, so anyway, it plays a sound effect and an emitter at the hit location, and this also spawns in the external strain at the hit location. The weapon, this just takes care of firing the projectile. So we call the fire event however rounds per second we have. So I have it set to 4.5 rounds per second. Yeah, so it just fires bullets repeatedly until the trigger is released, and then that will stop the function from firing. Over here we have our I damageable interface, which is responsible for the functionality that allows the player to be damaged. So it just takes in a delta amount, and the delta is the difference in health. So Damageable could also be used as a delta to increase health if we added health potions or med kits to the game. Over here we have our twin stick HUD, which has the health bar and the score have bound values. So the health bar has a bound value to, if we go over to the graph, we can see the health bar has a bound value to the player's health, which makes sense. So every time the player's health is updated, it also updates the health bar. Over here we have our binding for the score, which is bound to the score, which is in the twin stick game mode. So every time the score increases or decreases, I can't see a section where we would decrease the player's score, but if we did, it would decrease it as well. It just follows whatever the score is. Over here we have our game mode, which is responsible for our overarching values in the world. So what's our default player, what's our score, yeah, all that kind of stuff. So here is where we start. We get all actors of the enemy spawner, and then we get the first one. There should only be one in the world, but in case we had two, it'll just get the one, and then it will start spawning on only that one. On the player respawn, all enemies are removed from the scene to create a fresh start for the player so that they're not immediately swarmed, or so that they can also spawn in their spawn point in case the enemies are there. Yeah, so it gets all the actors of the enemy class and destroys them. And then it spawns a new hero character and sets it to be possessed. Not like a ghost possession, but where you have control over it. And then this is the increment score function called from the enemy class that will add the score, whatever score you provide, or it can decrease if you provide a negative number. I also just wanted to give a quick overview on how the destruction effect is created in Engine. So over here is one of our destructible objects, and you can see over here we have a option to show bone colors. So this will show all the possible geometry that can be split off from the mesh. So this is just a geometry collection, and so you have to go into fracture mode, which I'm already on. You would generate a new geometry collection, give it a name, put it in a folder, as you do, and then you will put the amount of slices that you want in the scene. So I put it in a bit weird as a minimum 500, maximum 20, but I got about an average and got 249 objects. So that's 249 slices to this geometry that can fly off when breaking down, and it'll also have physics, so if you break all the middle ones, the top will fall down, basically. Yeah, so you would do the slice there, and then a bit of an interesting thing that I have to do to get this to work is you have to set in the collision tab a generate overlap events. Otherwise the bullet will not interact with the object, and yeah, it'll be very confusing. So it took me a while to find that and to get my bullet effect working, but once I did, it worked, and I was able to spawn a strain field at the point of collision, and the objects started to fall apart, which was really nice to see. And I'm really happy with the effect that I was able to create. Thanks for watching, and I hope you like the project. Bye.